All right, guys, we left off on page 18. Let me recap some of the problems that we did. We'll do a little more practice with arc length until you guys get comfortable. And I'd like for us to start 1.08. So the goal is if we can do 1.08 today, do 1.09 tomorrow, then that will be Thursday, a free day for us to do quiz review and Friday. So that's why I like to push ahead so that we can earn that, or gain that extra day for review. Okay, so I talked about how if I want to find the length of an arc, right, the length of a portion of a circle, imagine taking that curved region and allowing that curved region to be flexible enough for us to straighten it out and measure it against a ruler. What would that length be? So your arc length, your S, is always going to be something that is not going to be radians or degrees. It's going to be like inches or kilometers or miles, right? Something that you can measure along a straight length. So, but we also talked about how the thing to be careful about with this arc length formula is that theta. We got to be careful about what is allowed for that theta. And the theta has to be in what form? Angle has to be in radians. It can't be in degrees, or if it is in degrees, we got to convert it into radians before we can use it for the formula. Okay. So we talked about examples 1 and 2, which were pretty straightforward because everything is given to you. We just put it into the formula. Radius is 8 centimeters, so 8 will go in for R. Theta is 4 radians. It's perfect. That's fine. That's the total radians. So we insert that into the formula, and we get 6 pi, which is the exact value. But we have to make sure that we don't put radians here, right? Arc length is in terms of centimeters. So even though there's pi there, we still want to make sure that our unit of measure is centimeters. Right. Number 2, same idea. Insert 12 in for radius, 5 pi over 6 for theta. Now, number 6 is where we need to make some adjustments, right? 300 degrees is in terms of degree. I'm sorry, 300 degrees is not radians, but it is going to be how we're going to get to theta. Okay. So we got to take that 300 degrees. The conversion is pi over 180. If I want to get from degrees to radian, I get 5 pi over 3. Multiply that together. I get my exact value. And then I can also get a decimal version if I multiply the pi through the calculator. Okay. Any questions so far? All right, let's work through number 4 together. Okay. While playing a game of chance, Jack flicks a spinner. Okay, this is a circular spinner here with a radius of 2 inches. So we can go ahead and put that information down. If the spinner swings through 2,665 degrees, and that just means that it's going to go through multiple rotations, right? That just means, 3, 4, 5 times maybe, but we don't have to worry about it. We just have to worry that theta is 2,665 degrees. How far did the arrowhead travel? So that is going to be arc length. So we're going to be basically measuring how far does it travel for S. So as it stands, can we take those numbers and insert into our formula? The radians, right? So what's the conversion rate? What's the conversion? I got multiplied by what? Pi over 180. And so I think for this one, it's okay if we have it in decimal form because that's kind of a messy number to deal with there. So let's just get a decimal approximation of that theta in terms of radians, because we can't do the formula unless our theta is the proper form. So insert that into the calculator, and let's just do a decimal value to 3 decimal places. What do we get? Say it again? 93.02. Okay, let me see. Yeah. Try that again here. Because you guys get that? 46.513. So we'll just do a decimal version of it, just easier to work with. So now that we have theta in the proper form, this is radians. Now I can find S. So that arrowhead is going to go through multiple spins, but if we were to measure its path, how far does it travel? 93.026. What's the unit of measure? Good, inches, not radians, okay? Or not degrees. Your arc length is always something that you can measure along a straight line. I'm sorry? Yes, that's right. So I'm going to ask you for units. Yeah, if I ask you for units of measure, that's going to be something that that's going to count towards full credit. What I did. That's fine. But if I ask you for the decimal version of it, you should multiply that pi back in and get that 93. Right? That's right. Yeah, do whatever the problem says, right? If it says leave it in exact form, then you'll leave pi in the answer. But I think for this problem, this type of word problem, I'll ask you for a decimal version, and so you'll just multiply all out. Yeah. Okay, let's go to the back. I just want to do a few of these so that we're comfortable, and then we can move on to the next section. Okay. But I do want to make sure that we get a few more problems under our belt so we can be a bit more comfortable. Okay, so let's see if we can just do the first 5 problems, and I'll work through the problems as you guys do them as well. Okay. So go to page 19. I'll just highlight the problems that we're going to do. Hopefully, we'll be comfortable enough to move forward. Subtends, all that means is that it's along the curve of the graph. Right? Sorry, of the circle. Curve of the circle. So number one, no adjustment needed. Theta is perfectly in the form that we need it in, so we can jump directly into the formula. Questions with one? Same formula, but now we're looking for different variables, so we may need to rearrange the variables around. It may not just be a simple multiplication problem here. Because they say that radians, that RAD is telling us that that's meant for theta, right? So the units kind of gives us an idea of what variable it must be referring to. Okay, number 51. Any questions so far, 1 and 2? Okay, 51 says find the length of arc S. Let me highlight that. How many degrees is a full circle? It's 360. Okay. Now, is that 140 the matching degree that is for our arc length? So the 140 is referring to this arc length. This arc length here needs to be matched up with a different angle measure. So what do you think is the angle measure that's going to be more appropriate for this part of the circle? 360 minus 140. Good. I will. So when I have a circle, okay, that angle measure is meant for what lives between those two endpoints, right? So the 140 degrees is meant to match up with this arc length over here, right? But it's not giving us, it's not asking for this arc length. It's asking for the other side of the circle. So if 140 is meant for this part of the circle, then 220 is going to be meant for the other side of the circle. Because 220 and 140 is 360, so we know that everything is accounted for within that circle. So that 140 is a little bit tricky. It's not quite what we need, but now we have a matching part that we're going to use. So we know that radius is 5. Theta is 220, but what further adjustment do we need to make? Got to convert it to what? Radius, good. Multiply by 5 over 180. Okay. Guys, let's do this for now. Let's do everything in decimal form, just so that we're not having to do the same answers for exact and approximation. So for these word problems, for these longer problems, let's just do the decimals so that our answers just feels less abstract. Okay, but 3.8. Yeah, 3.839. Okay, so now we have everything that we need. S equals R theta. You guys get 19. Oh, they didn't give us, sorry, they didn't give us a unit here. You guys get that?
I leave it with pi.
Yes, you can leave it with the pi. But for this problem, I'm gonna do the decimal version, but that's fine. Everybody okay? Yeah, sorry, there's no units here, so I just put unit, but if it was like centimeters or inches, then I would put that there. Okay, 52. Find the angle in the figure. What's theta equal to? To what? Not good radians. Okay, so I divided 10 by 5. Why is it not degrees? Okay, the reason why is because anytime we use the formula S equals R theta, theta is always gonna have to be coming out or involving what? Radians. So anytime I use the formula, it's gotta be radians. Either anything I get in return or anything I put in, it's gotta be in terms of radians. So let me go through the steps. So first it's S equals R theta. S is 10, because that's the arc length, right? That's the length of that part of the circle. 5 is my radius. I do 10 divided by 5 to get theta. Theta is 2 radians. Now, on the quiz, if I say, what is theta in terms of radians and what is theta in terms of degrees, then we'll make that adjustment. So if I ask you for theta in terms of radians, then you'll say 2 radians. What if I asked you for theta in terms of degrees? What would you do? How do you convert from radians to degrees? Multiply by 180 over pi. That looks kind of strange because maybe you're thinking, okay, I can't get the pi's to cancel out. So what happens? It's okay. You can just multiply this out, and whatever decimal value you get is the approximated theta for degrees.
It's they have two radians because 5 times 2 is 10. Radius stretches out.
Ask your question again.
It's usually it's 2 radians for the radius because of the weight 5 times 5 is 10.
Yes, essentially that's it, but I'm just going through my formula, right? I have S, I have R, so if I need to find theta, I'm gonna divide R from both sides. But yeah, technically it's this times this is always gonna equal that. Assuming that your theta is in the proper radian form. Okay, so 2 times 180 over pi. Around 114 degrees. Okay, visually that makes sense as well, because you see that angle is more than 90 degrees, it's obtuse. So visually, we can do it makes sense, right? Okay, try number 53.